Hey everyone. Today on our algebra journal, we're going to be looking at radicals and rational exponents. So we're going to start off by looking at exactly what does it mean when something is taken to the third power. So right over here we see that 2 to the third power, that means that we're going to multiply 2 times 2 times 2. So that's 3 times. That's supposed to be the word times. 3 times, so 2 times 2 times 2 is 8, so 2 cubed is equal to 8. Or maybe the way that we'd probably want to see that would be 2 to the third power is equal to 8. Now most of you probably already are familiar with that, but the other way, with the cube root, it says that it undoes cubing a number. So here's the idea. We're going to zoom in over here. If we have the cube root of 8, that's kind of like the cube root of 2 to the third power. Because remember, 2 to the third power was 8. Now the third root and the 3, they work as inverse operations, which basically means that they undo each other. So when they undo each other, we just get left with a 2. We can see that in a couple of ways. Let's start with the square root. So if we see the square root of 25, we need to think what is something to the second power. Okay, so 25 is something to the second power, and that's 5. So it's kind of hard to teach this because you have to have a pretty good idea about what all the squares are. So 5 squared. So now we can see, once we figured out that 25 is 5 squared, the 2 and the 2, they work inversely with each other, and we get left with just a 5. Now normally, we don't see square root with the 2. We just see it with just the root. So we just know that the square root works with the second power. It's the inverse operation of the second power. Let's do this one more time, and if we know that, let's try another number. Let's try 6. So 6 times 6 is 36, and times another 6, that's going to be 216. So if I want to know the third root of 216, well, that's like saying the third root of 6 cubed, because 6 cubed is 216. Now the third root and the 3, they undo each other because they are inverse operations, and we get left with just a 6. So that's the way that cubes and cube roots work. We can look at other powers too. Here we've got 25 to the fourth power. And actually we're going to skip this one. So never mind, I didn't say that one. This isn't the one I wanted to get to. Here we go. The nth root of a. Let's figure out what that is in our notes. And the way this works is that if x is the nth root of a, that means x to the n power is equal to a, which is the same thing as saying the nth root of a is equal to x. So again, they work like inverse operations because they are inverse operations. Now the radical is just that sign. The index of the radical is this number right here. Whatever that number is, that's the index. Now if that index is blank, then the index is 2. And this brings us to a few things that we can do which are interesting. So if we have, if n is odd, then the nth root of a is just a to the 1 over n, and it has just one real root. Odd means one real root. And I know we didn't see this over here because we should talk about this. Because if you see the nth root of a number, that's the same thing as that number to a fractional power. And that's kind of a weird concept, but it's something that we're going to be using a lot because it makes the algebra a lot easier. So for example, if I do, 3, or I wrote a 5 and I said 3. If I do 5 to the cube root, that's the same thing as saying 5 to the 1/3 power. Now there's no math to do there. That's just kind of a definition. If n, the index, is even, that means there's going to be 2 real roots. And we see that with square roots all the time. So if I do the square root of 36, that's equal to 6 or -6. So even roots have 2 answers. If n is even and a is equal to 0, then it only has 1 real root. And any root of 0 is just 0. And if n is even and a is less than 0, then there's no real roots. So for example, if I want to do the 4th root of -4, that doesn't exist because even power and negative value. Now I got to remind you that it doesn't always work. A negative inside the radical doesn't necessarily mean does not exist. For example, we know that -3 to the 3rd power, what does that equal to? That's -3 times -3 times -3 again, which is equal to -27. So if I do the 3rd root of -27, let's make that look more like a negative sign, that's equal to -3. So if you have an odd index and a negative inside the radical, then that's okay. The answer is going to be negative. Now our next core concepts over here is when we're talking about rational exponents or rational powers, okay? So if I see a to the m over n power, now there are 2 ways I can approach this. The first way is if I do a to the 1 over n to the m power. And then I could also rewrite that because 1 over n, that's the nth root of a to the m power. And then the other way to do this is to say a to the m power to the 1 over n power. And in this case, we can say this is equal to the nth root of a to the m. All of these are equivalent. This equals this equals this. So it usually doesn't matter what order you do them in, is what we're usually getting at. So we have this example right here, 27 to the 2/3 power. So 27 to the 2/3 power, that's like saying the 3rd root of 27 squared. Or it's like saying the square of the 3rd root of 27. Both of these are exactly the same. Now that was a heck of a lot of core concepts with rational exponents, things that a lot of students aren't very familiar with. So we're going to have to go to this extra practice and try and figure this out. So for questions 1 through 6, we're going to do the 2nd root, the indicated nth root of a. So if we're doing the nth root of 64, basically we're doing the nth root of a like this. So if we fix this over here, that's like saying the 2nd root of 64. And we have to reach into our thoughts and think, okay, well, actually 64 is the same thing as 8 squared. You're going to need a little bit of familiarity with the numbers in order to get that. And since these are inverse operations now, second root and second power, this is just 8. Okay, next one. Let's take a look at number 3. N is 4, A is 256, so this is asking for the fourth root of 256. Now that's a difficult one because we're not used to numbers that big. But if we play around with the numbers for a while, we can see that the fourth root of, well, 256 is the same thing as 4 to the fourth power. And you would get this familiarity just by grabbing a calculator and finding a bunch of the fourth power of things, okay? I mean, I can grab my calculator and say, well, what's the third power of 4? What's 3 to the fourth power? And that's 81. So not big enough. Let's try the next number. What's 4 to the fourth power? And that's 256. So bingo, we used our calculator to get to 256 here. And since, once again, we've got the index of the root matches the power, this is just equal to 4. Let's try it over here. We want the fifth root of 243. So I'm going to grab my calculator now. And I'm going to try the fifth power of a bunch of things. Let's try 2 to the fifth power. And remember, we're trying to get to, actually, I don't remember what we're trying to get to. Let's take a look. We're trying to get to 243. So we're going to try the fifth power of a bunch of numbers until we get 243. 2 to the fifth power is 32. Not big enough. Let's try 3 to the fifth power. 3 to the fifth power. 243. Bingo. So I got it. 3 to the fifth power is 243. So this is equal to the fifth root of 3 to the fifth power. Therefore, it's just equal to 3. Now, what if you don't have a fancy calculator like me? What could you do? Well, you can grab Google. So let's go to Google and let's figure out over here n to the fourth power. Oh, we'll do this one. The fourth root of 10,000. Okay, so we're going to go to Google and we're going to look for a calculator. And Google will give me a calculator. Isn't that great? So let's figure out, now the button you're looking for is x to the y power, which is this one right here. So let's start with 2. We want to do 2 to the fourth power. See that XY button right there. 2 to the fourth power, 16. Not big enough. How about 3 to the fourth power? Not big enough. We're trying to get to 10,000. So I don't know. Why don't we jump ahead? Let's do 5 to the fourth power. We're going to skip a few numbers. Okay, still not big enough. We're looking for 10,000, right? Yeah, we're looking for 10,000. Okay, so that's not big enough. Maybe we should fast forward and go to, let's try 20. 20. Ooh, that's not 20. That's 2. So let's clear everything. We'll do 20 to the fourth power. Ooh, I pushed the wrong button. Wow. Okay, so there we go, 20 to the fourth power. And whoa, way too big, 160,000. So this is too big. So I got to look for a number less than 20. Let's try 15. 15 to the fourth power. Okay, still too big. That's 50,000. I'm looking for 10,000. 12 to the fourth power. Let's try that. Okay, that's 20,000. And then why don't we try 10 to the fourth power? And yeah, that works. That's 10,000. So if you don't have a calculator, go ahead and just type calculator in Google. It'll give you a good calculator for this. So that's the same thing. 10,000 to the fourth, 10,000 is the same thing as 10 to the fourth power. And we made the index match the power. So they are inverse operations, and I'm just going to get 10. All right, let's do some more extra practice here. Okay, let's try, for example, maybe we should do this one, number 3. Now this is a negative number here, negative 216. So I need to figure out the cube root of some number to the third power. I got to figure out what that is. Okay, so we're going to take the third power of a bunch of negative things and see what we get. Let's go to my Google calculator, and let's start with negative 2. And all clear, and let's put a parenthesis so that, let's see, now there is no dedicated negative button, so we'll do negative 2 with a minus sign, negative 2 to the third power. Okay, that's negative 8. I needed to get to 216, so I'm kind of way off here. Let's try another negative number. Let's try negative 6. Close parenthesis to the power of 3. All right, bingo. Negative 6 to the third power is negative 216. So this is negative 6 to the third power. Just by guessing and checking, okay? Get a good calculator. You're in algebra now. And if you don't have one, use Google. So the indexes match. The power matches the index, I should say. So the answer is negative 6. Okay? Let's try 11. We've got 729 to the 1/6 power. Yikes. So that's the same thing as the 6th root of 729. All right, so we need to find something to the 6th power that's equal to 729. So let's try some numbers here. I'll go back to my calculator. Let's try 2 to the 6th power. That's just 64. How about 3 to the 6th power? 729. That's what we wanted. So 3 to the 6th power is 729. Over here, this is the same thing as 3 to the 6th power. The index matches the power. So this is just equal to 3. That takes care of the 7 through 12 problems. Now we know how to do those. For these ones, we're going to write this into a rational exponent. Okay, so that means a to the m over n power. So this one right over here, we got 4 to the 5th root of 4. So this is the same thing as 4 to the 1/5 power cubed. And so that we can multiply the powers, and this is just 4 to the 3/5 power. Let's do number 15. This is going to be 15 to the 1/4 power to the 7th power. So this is 14 to the 7/4 power. This one, we're going to go from the rational power to a radical form. So let's take a look at this. We've got negative 3 to the 2/5 power. So this is going to be negative 3 squared, and then the 5th root of negative 3 squared. Maybe I should have gone a little bit slower on this. Let's try this a little bit slower. This is 3 squared, negative 3 squared to the 1/5 power. And then that is the 5th root of negative 3 squared. Let's do number 17. I'll let you guys do 18 on your own. This one, 6 to the 3/2 power. So that is 6 cubed to the 1/2 power. So this is the same thing as the square root of 6 cubed. Okay. Now for 19 through 24, we're supposed to evaluate this stuff. So let's start with 19. We've got 32 to the 2/5 power. And I think we should do the 5th root first. So we want the 5th root of 32, and then we're going to square it. So let's figure out. There's some number squared, or some number to the 5th power that's 32. What is it? And we'll go to my calculator, and we're just going to guess and check. So we're going to start at 2. Let's try 2 to the 5th power. And whoa, that's already 32. So we're good there. This is 2 to the 5th power. Now we know 2 to the 5th power, the 5th root of 2 to the 5th power, that's just 2. And then the square is still along for the ride. And then 2 squared is just 4. Okay. Let's do 23 because this is kind of confusing. Now remember what I said before with the negatives? This is actually -1 multiplied by 729 to the 5/6 power because of the parentheses. Okay, it's probably easier to do the root first. So we'll do -1 multiplied by the 6th root of 729 to the 5th power. Let's try and find the 6th root of 729. So that's -1, the 6th root of something to the 6th power to the 5th power. Let's figure out what that is by going to Google, and let's try things to the 6th power. So let's try first 2 to the 6th power. That gets us 64. We need to get to 729, so let's try 3. 3 to the 6th power. Oh, it's 729. So 3 to the 6th power works. Right, so this is 3 to the 6th power. Now, the 6 and the 1/6, they are inverse operations. So my result is -1 multiplied by 3 to the 5th power. So what is 3 to the 5th power? Well, now the calculator can help us there too. We can just do 3 to the 5th power. Oop, I didn't do it right. 3 to the... Oh, it's not helping me. There we go. 3 to the 5th power is 243. So over here, this is equal to 243. Okay, and that is all of the ones we're going to do. Good luck, everyone. We'll be definitely working more on these rational exponents later. So I hope this helped you.